Hello, this is Michael with REI, and today we're demonstrating a program that REI developed as a proof of concept using a number of modern application tools, including Apache Drill, a database connectivity tool, as well as Amazon's Elastic MapReduce, which is a large data warehouse application tool, and a number of modern development techniques. This application uses data from the U.S. Customs and Immigration Service as the platform for this tool, aggregating data from multiple data sources and data types. So this application, first we use an applicant's immigration form number. This is called an A number, and we put a sample one right there, and we do a search. And what this application is doing is it's aggregating data across multiple data sets and correlating it. So we have application forms. So this particular user submitted these two forms, but also this application is aggregating data from their children, which is in a completely different data set. So it finds the correlations and finds their children and spouses. We can then drill down on a particular form and see that this is the applicant's information. We've structured the form to be just like the PDF form so that government users are familiar with the layout of the applications. We have accordion parts of the form so you can easily drill down on the particular parts that you want to see. When we go back to the search bar, we see the other applicants, and again we have the family forms. These are referred to as I-485s. And we can drill down on those as well. Again, all this data is hosted in Amazon's Elastic MapReduce, and we're able to correlate that data, these data sets, using a tool called Apache Drill. Also want to highlight a number of the other features of this. We go up here and we can see a number of the aspects of this development process that we used. First, we want to show that all of the code that we did is open source, hosted on GitHub. You can see the complete history of every commit that we made to the code. Also, we did a process called continuous integration and continuous deployment. So every time a developer checked in the code, we used a tool called Travis CI, which basically compiles the code on their servers and runs tests to make sure that it meets our code requirements, that all the functions are performing the way that we expect them to. And then after that is done, it actually deploys the code into Amazon after it's passed all the tests. Next we have Tableau. So we wanted to show different aspects of visualizing the data. So in this particular data set, we use data from the annual reports from the Customs and Immigration Service, and so we just show tabulations of where the data comes from. Again, over time, there's some dynamic aspects to it where you can filter it over particular time frames. We can also drill down and filter based on types of information that we're focusing on. And again, this is all dynamic in the nature that you can filter it over time. Another analytics tool we used was a tool developed by REI called Gov Dashboard. And again, this tool is able to query the database directly provided by Apache Drill. And so we're able to grab this data and graph it. And this is all happening in real time. Data. So we can see the process of the applications over time. So we're looking at the status of the informations. These are the ones that are on time, the ones that are overdue. We can also drill down and see the locations of the different applications, where they're coming from, and which service centers are actually processing those applications to see if there's possible bottlenecks in the service. Then we have a third Gov Dashboard data set. Again, showing the application processing time over time. Again, kind of looking for peaks and valleys to see if there's possible bottlenecks, maybe staffing solutions in terms of processing the applications. And then finally, we wanted to illustrate the ability to use other types of graphics for this application. So this uses a powerful JavaScript application library called D3, and we're just doing some simple bar charts. This is querying the APIs that are provided via Python, and so we are getting the number of 485 applications and the number of I-140 applications. Thank you very much. I hope you enjoy this demonstration. Please feel free to come to the website at any time to take a look. It's called D2D Flex at USCIS. And if you'd like to view the information, this is an excellent button to click on. Hello, this is Michael with REI Systems, and today we're demonstrating a proof of concept application that REI developed to use some of the latest tools that are available. Particularly, we were focusing on tools from Amazon's cloud services. This application is hosted in Amazon's EC2 cloud, but also we're using tools such as their Elastic MapReduce tool, which is a Hadoop framework that lets you host a very large-scale unstructured data sets that's able to aggregate that data over multiple database servers in a cluster. In addition, we're using a tool called Lambda provided by AWS, which provides an API services layer. We're able to rapidly develop API tools and host those in conjunction with your application. For the underlying framework of this application, this is an API-based application. The front end of the application uses AngularJS, and it connects to APIs that REI developed using Python Flask. So those APIs then connect to the database layer using a variety of different database tools. As we mentioned, there's Elastic MapReduce. We have MongoDB being used in certain cases, as well as MySQL. And we also have a tool called Apache Drill, which Apache Drill is a tool that's able to connect to multiple different databases and formats and provide that data in easy to digest formats for our analytics tools. So as far as the analytics layer, we focused on providing that functionality to multiple types of analytics tools, of which we used Tableau for this application, as well as an REI-developed dashboarding tool called GovDashboard. So let's get started. We have a Explore documentation button here. We'll get to that more in a second, but first we're going to go into the application. This uses A numbers from the Customs Integration Service. These are their unique identifiers for the particular applicants. So we provide a sample applicant number there. We paste that into the search bar. And what this application is doing is it's pulling all of the records that are associated with that particular applicant. So these records may be associated with multiple different forms that are submitted at different times by different people, and it provides a consolidated view. This is a capability that actually Customs Immigration doesn't actually have right now. They actually have to go to multiple different data systems to be able to get this information. So we're able to provide that in a single place with this proof of concept. So for this particular application number, they have two application forms. And what we've done is we've provided it in a format that is identical in the layout to the PDF documents, the physical paper documents that Customs Immigration Service uses. We did this in an accordion type of layout where you can easily drill down into the different parts of the application form. This is displayed as a read-only form. Again, this is to reflect the actual documents that were submitted by the applicant. We can go back to the search bar, and we also have their immigration forms for their I-485s that were submitted by their children or their spouses. Again, these forms may be submitted at an entirely different date and time, and they have their own status in terms of how they're progressing through the immigration process. So again, you get all that data in a single visualization capability. So in addition, we wanted to provide analytics for this tool. So we go to this drop-down bar, and we provide two different types of capabilities. First, let's focus on GovDashboard. Again, this is an analytics tool that is able to provide visualizations in a dashboarding platform. It's open source, hosted on GitHub. And in this particular visualization, we are grabbing data in real time through the APIs. This is interfacing with Apache Drill and grabbing this data to display application processing time, how long it's taking to process a particular applicant's data over a period of time, where the applicants are coming from, the number of submissions by different applicants based on country, which processing centers are processing the applications, possibly to find like bottlenecks in the processing time, maybe lack of staff for the resources. We have more visualizations of the data. Again, the processing centers over time, a neat little globe that shows where the applicants are coming from, what percentage of the applicants processing is either on time or overdue. And finally, the third visualization, again, grabbing the data through Apache Drill, which then gets it from the Hadoop Elastic MapReduce, and showing the monthly application processing time. See, that's declining over time. These are just random data sets that REI developed. They are not indicative of real data. We just wanted to show the capabilities of it. In addition, we used Apache Tableau, and this is another set of data sets that we were able to grab from the annual reports provided by Customs Immigration Service. We were able to grab data from 2004 through 2013, and just showing some of the capabilities of Tableau to process this data. Again, we're grabbing the data in real time. It provides it in a CSV type of format. Actually, this is using Tableau's public interface, and so we've exported that data into CSVs that are hosted in Tableau Public. Again, you can drill down into different types of visualizations for the data. You see different types of visualizations. You can filter on aspects of the data that you're interested in. And again, do it over time. And so this particular dashboard shows all the different types of visualizations that we did for this data. Finally, one of the goals for this application was to develop it as an open source application from the beginning. And we wanted to use modern continuous integration and continuous deployment services. So all of the application is hosted in GitHub. It's open source. You can see the entire development history of the application in terms of every single change that was made to the application, when it was made, what changes were made. And we can also see the contributors to the application. In addition, we used a continuous integration and deployment process. We used a service that's free for open source programs called Travis CI. For non-public applications, we typically use another open source tool called Jenkins, which we host in-house. So what this tool does is after every commit of the application, every time the developer makes a change to the code, it deploys that code in a test environment, and then it runs all of the tests for that application to make sure that it's passing all the different types of validations, other types of issues that could cause the problem to malfunction in production. If there's a problem with any of those tests, if there's a problem with the building of the code, notifications go directly back to the developers saying there's an issue and you need to fix that right away. So here's an example of a code base where the application build failed. We can also see the entire build history of it. So if we scroll back a little bit, there was an application where we were testing out some new capabilities for testing with Selenium and using a tool called Browser Stack. And so the developer was working on that a couple of times until they finally got it to work right. So then we get a nice little icon here saying that the build passed. And after that is done, it actually deploys the application to Amazon. And so it takes that code, checks it out of GitHub, and puts it on our Amazon servers, where we can do either more manual testing, or you can promote it to your other environments, such as your QA environment or production environment. So we hope you've enjoyed our demonstration of some of the modern application processing tools such as Elastic MapReduce. Apache Drill we've become big fans of because it lets you integrate with multiple types of data sets in different data formats, whether it's structured or unstructured data, and it lets you easily be able to provide these sort of tools through API interfaces. REI's in this particular case using Python Flask to provide these API interfaces for either Tableau or other types of visualization tools such as Gov Dashboard. Thank you very much.